In this video, we'll be reviewing two types of bonding, ionic bonding and covalent bonding. And then we'll learn about two specific types of covalent bonding, nonpolar and polar. When atoms bond, they gain, lose, or share electrons to achieve a stable electron configuration. That is, a noble gas electron configuration. The atoms that tend to gain electrons are nonmetals. The atoms that tend to lose electrons are metals. And atoms that share electrons, well, this often occurs between two nonmetals. Let's look at ionic bonding first. Ionic bonding forms between a metal and a nonmetal. During ionic bonding, an electron is transferred. The classic example is sodium plus chlorine. This electron from sodium here will be transferred over to chlorine. To make sodium chloride. So the way that this sodium achieves a stable configuration is by losing an electron. The way this chlorine achieves a stable configuration is by gaining an electron. And remember, a stable configuration is an atom that has 8 valence electrons. One way we can represent this reaction is using little cartoon pictures of the atom with an electron cloud surrounding it. When sodium loses its electron cloud gets smaller. When chlorine gains an electron, its electron cloud gets larger. The transferring of the negative electron has resulted in sodium having a positive charge and chloride having a negative charge. And it's the attraction between this positive and this negative that holds the crystal together. That's ionic bonding. Now let's look at covalent bonding. A covalent bond forms between two nonmetals. In a covalent bond, electrons are shared. There's two types. Remember, they're nonpolar and polar. Let's first look at nonpolar. In a nonpolar covalent bond, electrons are shared equally. And it often occurs between two identical atoms. Let's look at chlorine plus chlorine. This chlorine has 7 valence electrons, and this chlorine has 7 valence electrons. They each want one more valence electron. If the electron were to be transferred, one would have 8 and the other one would have 6. So that's not good. So what they'll do to achieve 8 is the electron will be shared. So these two electrons are shared between the two chlorines. So if you look at this chlorine, it has 8 electrons surrounding it. If you look at this chlorine, it also has 8 electrons surrounding it. So now both chlorine atoms are stable. One way we can represent two shared electrons is by drawing a dash, and this is a bond. A bond consists of two shared electrons. This reaction can be illustrated again using electron clouds. You'll notice that this electron cloud or electron density, I've drawn it in such a way that it looks like the electrons are being shared equally between the two chlorine atoms. So that's nonpolar covalent. Let's take a look at polar covalent. In a polar covalent bond, electrons are shared unequally. They're still shared, just unequally. And it usually occurs between two different nonmetals. Let's look at hydrogen plus fluoride, or plus fluorine. Just like before, they're going to share these two electrons. However, for reasons we'll learn about next, fluorine likes electrons more than hydrogen does. So these shared electrons here are not shared equally. Fluorine likes them more. It's almost like a tug of war, and fluorine's going to win. They'll still share, but the electron density will be closer to fluorine. It can also be drawn like this. Now let's draw the electron clouds. Notice the way I've drawn it here is the electron density seems to be more dense over by fluorine, indicating that fluorine likes electrons more. So that's polar covalent bonding. So in this video, we looked at ionic bonding and we looked at covalent bonding. In ionic bonding, the electron was transferred, and in covalent bonding, the electron was shared. It was either shared equally or unequally, depending on if the bond was nonpolar or polar.